Welcome to NPA teaching. In the last video, we have discussed the singular and non-singular matrices. Once again, I am reminding you that a singular matrix is one whose determinant is 0, which means there exists a linear dependent relationship between at least two rows or columns. At the same time, a non-singular matrix is one whose determinant is not equal to 0, which means there exists a linearly independent relationship between its two rows or columns. Now I am discussing the rank of a matrix. The rank of a matrix is defined as maximum number of linearly independent rows and columns in the matrix. It is equal to the order of highest order non-singular square matrix, that is non-singular square matrix is one whose determinant is not equal to 0. Contained in a given matrix. Thus, a rank of a matrix is a simple test of linear independence. A rank of a matrix cannot exceed its rows and columns, whichever is smaller. The rank of a matrix is generally denoted by row A. Assuming a square matrix of order n, if row A is equal to n, then matrix A is non-singular and there is no linear dependence. If row of A is less than n, A is singular and there is a linear dependence. Consider the example of 2 into 2 order matrix. Matrix A is equal to 6, 4, 7, 9. Then the value of determinant of this matrix A is equal to 6 into 9 minus 4 into 7, which is equal to 54 minus 28 equal to 26. So here the value of determinant is not equal to 0. Hence, given matrix A contain a non-singular matrix of order 2. Hence, rank of matrix A is equal to 2, which is written as row 2. In this case, we are able to find a highest order of non-singular square matrix whose determinant is not equal to 0. That means here the maximum number of linearly independent rows and columns in this matrix is equal to 2. That is row of A is equal to 2. But consider the second example of matrix A, 2 into 2 order matrix. Matrix A is equal to 4, 6, 6, 9. In this case, the value of determinant is equal to 4 into 9 minus 6 into 6, which is equal to 36 minus 36, which is equal to 0. So here the value of determinant is equal to 0. So matrix A is a singular matrix and two rows and columns in this case are linearly dependent. Hence it is not a null matrix. The row of A is equal to 1. Consider the another example of 3 into 3 order matrix. Determine the rank of A of following matrix A. Matrix A is equal to 3, 6, 5, 2, 1, 8, 7, 9, 1. In this case, the value of determinant is equal to 166, which is not equal to 0, which means it is a non-singular matrix and 3 rows and columns are linearly independent. Hence the row of A, that means rank of matrix A is equal to 3. We are able to find the maximum number of linearly independent rows and columns in this case of matrix is 3. That's why rank of A is equal to 3. Consider another example of 3 into 3 order matrix. Matrix B is equal to 5 minus 9, 3, 2, 12, minus 4, minus 3, minus 18 and 6. Now after the calculation, the value of determinant we get 0. With the determinant value of B is equal to 0, matrix B is a singular matrix and the 3 rows and columns also are not linearly independent. Hence, row of B is not equal to 3. Therefore, rank can at most be 2. We want to check whether the rank of matrix is 2 or not. Now test, that is it possible to construct at least one non-zero determinant order? For that, we want to start with a sub-matrix in the upper left corner, that is take a 2 into 2 determinant. In this case, first 2 into 2 determinant is 5 minus 19, 2 and 12. And consider the determinant of this 2 into 2 order matrix, that is 5 into 12 minus 9 into 2, that is 60 minus 18, which will give the value of 78. So the determinant value of submatrix is not equal to 0. Hence row of B is equal to 2. There are only two linearly independent rows and columns in this matrix B. In this case, there is no need to take the another submatrices from the given matrix of B, because the first submatrix is already given the positive value which is not equal to 0. Hence the row of B is equal to 2. At least two rows and columns in this matrix B is linearly independent. Consider the one more example of a 3 into 3 order matrix. Determine the rank of following matrix A. Matrix A is equal to 1, 2, 3, 2, 4, 6, minus 3, minus 6, minus 9. After the calculation, the value of determinant in this case is equal to 0. Hence, the determinant value is equal to 0. Matrix A is a singular and the three rows and columns are not linearly independent. Hence, the row of A is not equal to 0. Therefore, the rank can be possible to be 2, but we want to test whether it is 2 or not. To check this, we want to find out, is it possible to construct at least one non-zero determinant order matrix from the given submatrix. For that, we are starting with a submatrix in the upper left corner, taking 2 into 2 order determinant. Consider first 2 into 2 determinant from matrix A, that is 1, 2, 2, 4, and the value of determinant in this case is 1 into 4 minus 2 into 2, that is 4 minus 4, which is equal to 0. Hence the determinant value of this submatrix 2 into 2 order is equal to 0. Now consider the another submatrix, that is 2, 3, 4, 6, and we want to check the value of determinant, that is 2, 6 is equal to 12 minus 3 into 4 is equal to minus 12. So 12 minus 12 is equal to 0. Again it is the value of determinant is equal to 0. Now consider another submatrix, that is 2, 4, minus 3, minus 6. Now we want to find out the value of determinant in this case is equal to 2 into minus 6, which is equal to minus 12, minus 3 into minus 3, that is minus 12. So minus 12 minus minus 12, which is equal to 0. As the determinant value again come out with 0, now we want to check the another submatrix, that is 4, 6, minus 6, minus 9, and the value of determinant in this case 4 into minus 9, which is equal to minus 36, minus 6 into minus 6, which is equal to minus 36. So minus 36 minus minus 36 will become plus. So minus 36 plus 36 will become 0. Again come out with 0. Now we want to check the another submatrix from the matrix A, that is 1, 3, 2, 6. In this case, the value of determinant is equal to 1 into 6, 6 minus 3 into 2, 6. So 6 minus 6, which is equal to 0. Now the last possible submatrix is 2, 6 minus 3 minus 9, and the value of determinant in this case is 2 into minus 9, which is equal to minus 18, and 6 into minus 13, which is equal to minus 18. So minus 18 minus minus 18 minus minus 18 will become plus 18. So minus 18 plus 18, which will equal to again come out with the value of 0. Therefore, the determinant A of matrix A is equal to 0, and all the second order determinant are again come out with 0. Hence, rank of matrix is not 3, which is also not equal to 2. Again, the matrix A is not a null matrix. That means it is a positive values in the matrix A and submatrices, and hence the rank of matrix in this case is equal to 1. So rank of A is equal to 1. Thus, I hope you are clear about the rank of a matrix. If you are not subscribed to my channel, kindly subscribe to get the updated video by clicking subscribe button and bell icon. Have a nice day and see you in the next video. Thank you.